They are going to build the keynote that he wants. Orbit's going after him and he's gonna walk. And then the other two are gonna sit at the podium and then there's a Q&A.
Oh, so they're gonna sit there. Okay.
Let me gather it.
Okay, go on.
Okay. Ooh.
Maybe I'll do the morning logistics. She'll talk. I've done these about 400 times.
I haven't. So
It's really bad at this point.
They haven't seen you do before the station.
Yeah, exactly. You don't know.
I'm new to the job. They have no idea what I'm going to say to that microphone.
That's the excitement about it.
There's this great video of my son who was the kindergarten. There's this son in school. He had to some part of this, like, kid says something, kid said something, kid said something. So they handed my son and he went way off script. Just went on this monologue. And they had to like take that microphone with him. I have video of it.
You had a teeter come out of your eye. Like,
I would like to introduce everybody. This is Circus by Britney Spears.
It was more or less something like that. It was not great. Yes. It was like a stand-up show right there.
it just flew in, and boy, are my arms tight.
Yeah, and that's what I've been is doing our taking work day in the past hour. Squeezing that in before I came over here.
I'm glad you got to do that for
Yeah, and then I turned them over to their grandfather, who is also an employee here.
That works out perfect.
They're off to go talk to Bluey in our artificial intelligence lab. We have an AI agent of Bluey over there. And I have big questions, but I'm missing it. I want to hear what I'm
They're going to solve. They're actually going to close some high and super difficult problems.
They just put in all of the scripts.
And that's how future works, kids.
or a little closer together?
A little closer together.
Good morning.
Still. Okay.
What are you looking for?
This is on wheels.
Are we able to scoot that a little bit forward? Because I think some of us will be using the podium.
You want to use the podium, or do you want to use a handheld, or do you want to use a wearable? You got to use all your options.
Wearable, but if we can just move the.
Like a grenade. Right back front.
Pretty sure it's
This will be right.
Oh, yeah. This is hot right now. So.
Thank you. When you're done, just.
Hey, orbit.
Test.
You can turn it off if you want. Free walking call.
Come on, Dan, join in.
It's not free bird?
No, but this is where we had the Lamborghini, which is really not my vibe. That's why
So my go-to is water by Max Percent. So
also cool. Mine is
Shine is tequila.
oh yeah, he's you know they want to.
Tequila. Just stand up there for another 18 more.
It's easy enough, but when you do it, you take a shot and then you get 4 shots.
I didn't realize how close we were to hearing about it. I grew up north of the house, so I used to go there every summer, and we'd go to.
for summer, man, I love it. There's nothing in there.
You go for the tail. And then are you from this? Oh, did you? I grew up.
I got mine with me. That's orbit.
Did they tell you how to, I'm loud, I'm sorry.
That's why I can go.
Powered up, that should be good for you to go.
Great.
Yep, there's your voiceover.
Wow, that was fast.
So you can walk along, have a good talk.
Do you have my slides by chance?
Yes, I do. Yeah. Your slides printed out? I don't have them printed out.
Just want to flip through. Thanks.
Orbit's trying to get your
Okay. I mean, I could just leave.
The whole time. When you sit down, which I told you already,
I could just go.
not like back off, so that it doesn't mess up the other mics.
Why am I sitting down?
You're gonna sit down
And
after you talk, so you can get up, you can wander around and talk, and then when you're done, sit down.
Got it.
Orbit's gonna come out, and he's gonna wander around and talk, and then when he's done, he's gonna sit down. And then Liz and Sean are gonna get up, and they're gonna wander
You
around.
got all my cellular
You're
devices.
gonna sit down, and then you'll all take questions.
Do you have a pen?
Before you do that.
I don't. Okay, slides right here.
Okay, I don't like the amount of people are in here right now. Dan, can you go yell at people on the intercom, please? Gonna give it a couple minutes. Okay, now that I know you can actually hear me outside, come into the auditorium, please. I said please. There we go. Now we're cooking with gas. Well, I forgot I was live streaming out there so they could actually, I was like, okay, I started coming in. I like it. Now they're coming. They have data. Make sure data has the help. We did a panel together at a Black Tech Week. She's with NASA. There we go. Wait, am I on the webcam looking like this right now? Oh. Okay. Let's get everybody to quiet down. Everybody hold your hand up if you can hear me. Oh, look. You're still following directions on the third day. I'm very proud of you guys. Okay. So we're very excited. We've had a really good first 2 days. And today we're going to do a lot of fun stuff, right? Because we're going to get into the nitty gritty. We're going to have all these good breakout sessions. We're going to hear from DARPA and our Lunar 10 effort. So I don't want to waste time because we already started 3 minutes late because we had to go find all of you, but it's okay. We'll let it happen today. I want to give just 2 announcements before we get started. If you have rolly bags, because we know a lot of you are flying out today, you can stick them kind of right outside here on the right so you don't have to pull those around, and I don't think anybody's going to take them. I promise. Well, I don't promise. I don't think anybody's going to take them. And then the other is you will see the breakout signs. Everything's already labeled for the day, so there will be a breakout in here, and there will be a breakout in the dining area. We'll try to push everybody over to one side, okay? So what I would like to do now is bring up Dan Weinbauer. He is our new Deputy Program Manager for LSII, and also the Program Manager for Logic.
Good morning, LSIC. I hope everyone is really excited for our third and final day together. And I want to take a moment, first of all, and want to say thank you to all of you. This has been my own first spring meeting, and this has been just, the best. Your participation has been absolutely fantastic. And for those of you who haven't had the chance to meet me yet, I am Dan Weinbauer. I am the Deputy Project Manager for LSII, as well as the Project Manager for DARPA's Logic program here at APL. And I have the distinct pleasure of introducing our keynote today, Dr. Phil Root. Dr. Root is the Director of the Strategic Technology Office at the Defense Advanced Research Projects Agency, charged with providing technology development to give national security leaders trusted disruptive capabilities to win in all physical domains and across the spectrum of national competition. He has previously served as the Deputy Director and Acting Director of the Defense Sciences Office at DARPA and as the Program Manager in the Tactical Technologies Office. Dr. Root has also served a distinguished career as an officer in the U.S. Army, and he is a graduate of the U.S. Military Academy at West Point and holds both a master's and a PhD from MIT. Please join me in welcoming Dr. Phil Root.
So thanks for the introduction, Dan. No, let's just see what happens if I don't advance them. Yeah, I should do that. Appreciate the introduction. All of it's true, and some of it actually happened. I am Phil Root, and I have a lavalier mic. I'd love to walk through here and see where there's a dead zone, but you would probably appreciate hearing, rather than my interest in a public announcement, what directions DARPA is going in conjunction with APL, in alignment with NASA and STMD. So we are here because we assigned ourselves homework to tell you what we were thinking. So we want to report out on that homework. I'll take a couple minutes and turn it over to Orbit, who will fill in much more granular detail on that. But I wanted to start with, that's me, what is DARPA doing in this sphere? So February 7th, 1958, President Eisenhower started DARPA. What else happened that year? NASA. We were born from the same DNA. We were born from the same event, that is Sputnik. We've been together from the beginning, and we're propagating that forward now. Sputnik, that started this conversation, started DARPA, started NASA. We're propagating forward to say, what is the future surprise? But rather than being the result of the surprise, how could we surprise perhaps even ourselves, our skeptical selves? How can we surprise the international community and set international norms in a way that's deeply desirable to us as quickly as possible? We don't know the answer, but we have hypotheses. And so throughout, what we have said is we have some hypotheses in how we can catalyze the current situation and really work and align with NASA. I keep pointing at Spuds and Jim. I'm sure there are others I should be pointing to, but I'll gesticulate this way. How can we align, complement, and what can we do to assist? And if we can't, then we have proved the null hypothesis and we should get out of this business. But we're here to report out on areas where we think we can contribute. We have 3 plays so far. We've made 3 plays. We'll report out on Luna 10. That was a solicitation and a short program to go see what could a thriving lunar economy look like. In fact, it's one of my favorite solicitations, and Orbit will outline the first line here momentarily. I won't steal his thunder. I'm already stealing enough. But then to make it real, we asked APL to, again, in conjunction with LSIC, in conjunction with this community and in alignment with NASA, how do we make this real? And we make it real by interfaces, by standards. And standards, to the uninformed, might seem boring, but standards is how you make progress. 3GPP set international telecom standards, and that led to massive industries. In a similar way, we're hoping the creation of standards catalyzes the commercial economy, as well as takes input from NASA as an anchor tenant. What else could we do and move quickly? And then we formalized our thoughts of these hypotheses in the Shale RFI, where we said we have 6 hypotheses for accelerating the lunar economy, Shale. We don't think we got them all. In fact, many of your answers said, close, but you should be thinking about this. If there are other things we should be thinking, we hope that you let us know in this forum. There are feedback sheets if you want to drop those off, or in the breakout sessions. So please hear our plea to let us know what we're missing. A lot of good to see you. So 3 plays so far, and your question is, what's next? We believe that our initial hypothesis that investments, technology maturation for the lunar infrastructure might make a significant difference, and again, catalyzing the lunar economy. We believe that Luna 10 has supported that hypothesis, and I want to show you some details. So our current set of working hypotheses are the following. We believe that there is an approach for DARPA to demonstrate a push from individual self-service to commercial multi-service. Don't yet have the right words. Words meaning, do we call this collective or aggregation? In my mind, it's an outpost. It's a commercial outpost until perhaps there's a larger thriving economy. But an outpost has a sense of isolation. But can we aggregate aggregate infrastructure within this outpost that catalyzes and really centralizes economic activity? And we believe that, and Orbit will report out why we think that is actually sustainable. And we have a technological and economical, fiscal reason to believe that. And so that supports the second, which is this push from government as a sole sponsor to commercial as a customer. And one thing you saw in shale is a pivot from pure infrastructure to some questions about anchor tenants, meaning you don't just have infrastructure that serves each other, someone has to be the anchor tenant. Clearly, NASA would be an ideal anchor tenant. We are well aware of the need to support their exploration and science missions, but then we're wondering who are the other anchor tenants, what should we be prepared for? More about that here momentarily. And then importantly, you don't do this in the abstract, so we're thinking about what are the inputs, outputs, and limitations, meaning if we're going to make a business environment, we're not setting winners and losers, but if we're going to create a business environment, then you have to know what are these inputs and outputs. This is so much fun, right? This is every day, it's imagine a world where, and we continue to refine, okay, what are we imagining today? And then at some point, your imagination trails off, and so you have another cup of coffee, and you imagine another. And so we're going to report out on where our imagination has taken us so far. So when we announced the initial service providers, as you see here, announced that we roughly looked at the large number of proposals, great proposals, thank you, many of you, for proposing, and said we're going to bin it in this way, but these are not the winners. We said these are the people that just signed up to represent the entire community. So you're going to see their logos, but really they had the responsibility to cleave off, and if you recall the solicitation, to cleave off their engineering team, at least 5 members, to full-time support Luna 10 in collaboration with each other. So this is my hand gesture for an n-squared complete graph where we had 14 players, and I don't have that many fingers, unfortunately, so imagine a world where I had 14 fingers. No, imagine a world where every week the DARPA team said, okay, here's your next homework, and I'm going to steal a bit of thunder, but it started from n-squared, then it became bilateral. Okay, you and you, figure out what you're going to do together, what are your value streams together, but you have to represent the entire community. And so Orbit's going to respond out with the results of this, this extended structured conversation. So again, you see icons here, pun intended. You see their graphics here. The intent was for them to represent the community. One thing that we learned were some very specifics about value chains. I want to share what we learned because I think it's important to proceed with engineering humility. Humility meaning we didn't know it all going in, otherwise we wouldn't have done this. And this is something we learned, the amount of interfaces necessary to pull together a single value stream. So a value stream here, we embark, we land, and we deliver something. That seems very straightforward. And what we found is that in order to deliver that, again, you see their names, they represent capabilities. And so think of Crescent in robotics, Redwire, not robotics, in PNT, position, navigation, timing. Same with Redwire. SpaceX does the delivery. Again, this is placeholders for their industries. But look at all the interfaces necessary where you have to do a handoff from one provider to another. There needs to be an interface to standardize how does that occur. We have such interfaces in terrestrial industry. And so the question is, what are the interfaces that we could develop, again, with our NASA teammates to actually say such a value stream could be viable, hence someone could actually provide value and receive compensation. If you can't receive compensation, then you can't have a thriving economy. So wrapping up with the 6 hypotheses we're working on, this gives you an indication of what we're currently thinking. Wanted it to be explicit in our current thoughts, and so we had 6 hypotheses. We have your responses, those that chose to respond. Thermal rejection as a service, that was another lesson learned. Did not see that coming. The lesson learned was all entrants to the commercial economy would benefit, or at least potentially benefit, from a shared thermal rejection as a service. Everyone has to do that. Maybe that would simplify all lunar entrance. Widespread lunar prospecting, that became clear as a catalyst, not a huge surprise there. 2 thoughts on anchor tenants, large silicon wafers and biomanufacturing. Another was concepts to improve refinement rates, and Orbit will talk some more about that. And then new concepts for PNT. The reason we're thinking about new concepts for PNT is we're thinking what scales most quickly. Because there are many approaches to PNT, particularly in that environment. It's not terribly hard. But what's terribly hard is we want to provide that in this decade. What if we want to provide it before this decade? What if we want to provide it in months, not years? What could scale favorably then? And maybe there's a DARPA play there. So thank you for all those that responded. And with that, I'd like to turn it over to Orbit, who probably will gesticulate somewhat less. But I would encourage you to stay connected to us, to this community, to APL and the NASA team. Why? Because we believe we are one day closer to some future we can imagine, one day closer to a need. And so it inspires us to sleep very little and engineer a great deal and hopefully deliver this on behalf of all of humanity. So thank you, and over to Orbit for next.
Awesome. Thank you, Phil. I appreciate that. That was a great introduction to our goals. And so now we're going to peel the wedding cake one more level down and dig into a few of the details. As Phil mentioned, in the fall at this very meeting, we unveiled our consortium of Luna 10 performers organized into these key services that we thought might be able to be monetized over the next 10 years. Power, mining and construction, transit and mobility, comms, PNT, all underlined by market analysis, early market analysis. Now, we started with some industry-leading companies, several with plays in multiple commercial domains. 13 are still part of the program, and they are all here today. So please find them during the follow-on Luna 10 breakout sessions. Ask them questions. We really want to dig into what we have not thought of, what we have forgotten. So Phil did a great job in framing these questions in terms of why DARPA. I'm going to focus on the third one, which is the inputs, outputs, and limitations. So 6 months after getting underway with this program, I think we've arrived at a good understanding, and you saw the preview of Shale, of what we think some of the DARPA hard questions might be to close on this lunar economy very quickly. What I'm going to do is cover at a very high level what our 13 performers brought to the table. So here's how I'd like to ask for your help. If you would like more details on each of the performers, guys, I'm going to give you 90 seconds. I hope you guys have all had your coffee. There's 13 performers. They all stitch together in different ways. So if you would like more information, because I guarantee you I don't have enough, please scan that link on the left with your phone, and you can find more information. And remember, these folks are here. So think of this as your background for the session that happens later. As I mentioned, we have a breakout session later. The first half of that session is dedicated to in-person show and tell via a poster session. And then for everyone, both here and online, if you have questions for myself, for Dr. Root, for any of the government team that follows, please scan the QR code on the right. That is the Slido link that you all know and love by now, and that's how you can get your questions to us. We'd love to hear what we forgot, get your feedback, and get your questions. This QR code will be back up in a moment if you didn't get it now. So with that, here's my fast and furious summary of over 25,000 person hours of labor. I'll take you through a really quick summary of each of our performers, the investments that they are making, and then I'm going to hand it over to representatives of our government integration team to tell you how they link together into a possible lunar framework. That's the next level of the wedding cake. Okay, going in alphabetical order. Blue Origin proposed 3 complementary nodes: a lander node that can host payloads and services from other companies. This is also an infrastructure node that could provide power wirelessly to mobile users through optical wavelength wirelessly beamed power. Blue also brought some of their ISRU capabilities to the table. On the bottom left, you can see a blue-centered framework for how they could fit in an interface with other commercial entities. And you're going to see this version, each company's version of this as I step through this. And the next presentation is going to tell you how that all stitches together. So next, Lunar Industries brought metal mining and recycling. They are building a foundry that can accept aluminum and iron that's extracted from lunar regolith, and then output, as you can see on the far right, useful elements for building out a lunar infrastructure. That's ingots, beams, sheet metal, really anything that's metal-based that could be used. Things like anything from robotic repair to building a lunar mobility system like a railway on the moon. This foundry, interestingly, can also accept scrap metal from other defunct lunar hardware. That recycling ability becomes a new monetizable service for the lunar economy, especially when each kilogram costs so much to take to the surface. Crescent Space is building a night survivable modular unit for comms, PNT, and space traffic management, all in one low swap unit. Again, as Phil mentioned, these companies are representative of larger services, and there's a huge amount of products that are being offered in comms and PNT. The interesting thing about this is scalability. It can be scaled up or down, depending on user needs. So if I start with the red must MVP, just 0.7 kilograms, that's something that can go on an astronaut or a really small rover, all the way up to must heavy, which can be hosted on something like an infrastructure node or a lander and provide night survivable local mesh networking. Next up, FiberTech brings power to any lunar infrastructure node. So this is another scalable modular unit. This is for wirelessly beamed power and laser communications. So if you're a rover like Viper that's headed down into a dark place that never sees light, or you're mining for ice and water, then this is how you can receive enough power to survive that expedition long enough to monetize, right? Because that's our goal. So if you just need power for mobile comms or a robotics unit, then you don't need that much power, and perhaps you could pick something like the Lion Nano, and that scales all the way over to mining operations or power-intensive activities like building a landing pad, and more on that in a moment. All right, everybody caffeinated yet? We going? All right, we're gonna go. Firefly Space, next, took a fresh look at a harbor in cislunar space that can serve as a node between the Earth and the moon, right? If we're taking stuff to the moon, then we want to think about logistics. So think about these as deep space ports for those in-space logistics. Spacecraft go to the moon, they drop off their lander or their lunar orbiter, and then they return to this node. So think about this as a shift in paradigm away from satellite end of life towards satellite retirement. You plug into the harbor, you share your existing fuel and comms and power from solar arrays or compute. As this hub builds out, then it starts to provide services to you. Things like refueling, edge compute, hosting space domain awareness payloads. So think freight and harbor services to power the orbital and surface lunar economy. Gitai is providing robotics as a service, as an enabler to the lunar economy. I think I have personally come to a new appreciation for how robotics can enable almost every other service. Are you an ISRU plant that needs regolith dumped in? Then you call a robot loader. Are you a foundry that's manufacturing rail beams and you need that moved to the construction site? You call robot transport. Are you an infrastructure hub that's aging? Think robotic maintenance. I think my hypothesis is that it's going to become a commercial requirement for a lot of services as they're starting to design lunar units with robotic integration in mind. Now, Helios is the first of our 2 ISRU companies and a great example of how thinking as a framework instead of as an individual service can create additional value. I'll draw your attention to the hot DOR, deoxygenated regolith. This is waste from the oxygen extraction process that can be passed to, for example, Cislunar for metal extraction, or used by one of our other companies I'm about to show you to build landing pads on the moon. The interesting thing we found is that the commercial value is actually in the heat of the deoxygenated regolith itself. So that, because that's heat that the landing pad company or the metal foundry don't have to put in themselves to heat things up. But getting this waste from the ISRU plant to that user that needs it in a timely manner, that's robotics as a service. So hopefully you're starting to see the links, right? The output of one process can be the input to another. And I think this matters, especially where we are today, which is $1 million per kilogram to the surface of the moon. Those links are how we lower barriers to entry and increase early profitability and get this economy started. So the next presentation is really going to focus on, actually, you're just going to see a snapshot of a much larger analysis that we've done to put some numbers to those statements that I just made. All right, Honeybee Robotics has the idea of utility towers. So these can be anywhere from 30 to 200 meters tall, and they can be deployed in a single launch, even at the 200-meter scale. These towers can host services on the masthead at the top that need elevation for line of sight. So as the figure on this bottom left shows, the taller that you get with that tower, the more line of sight you have. And this matters for line of sight power beaming or comms or data transfer. Alternately, you can plug into the base of the tower and receive services, things like power from that massive solar array, or thermal rejection and generation, as Phil previewed. Okay, Icon, I mentioned earlier, this is the landing pad company. They're a construction company that's using a laser vitreous multi-material transformation, or laser VMX, to sinter lunar regolith and create landing pads. I am also a pilot, and so I think of this as a lunar FBO for all you pilots out there. Dust is obviously a huge problem on the moon. I think everybody in this audience appreciates that, especially for heavy lift vehicles like Starship. And so we think landing pads will absolutely be a monetizable service. Laser VMX can also build other foundational infrastructure nodes, things like roads, to increase the speed of transit and reduce dust. Now, in the next talk, you're going to hear about the 4 ages of the lunar economy, and technology like this is a key part of progressing from the age that you're currently in to the next age. But this is also power intensive, of course. So this VMX unit is a great example of both purchasing services on the moon and then delivering a service on the moon. Now, logistics is the lifeblood of any economy. And this concept filled a big hole that we felt that perhaps was not being thought about enough. Starship is going to land tens to 100 tons of stuff on the moon in one shot, and that's great. But what happened when we saw single-digit tons sent on a C-5 to Bagram Airfield, for example? It just sat there until somebody really needed the stuff that was all the way at the bottom of the pallet. So if you're a commercial company whose business model depends on what's being delivered by Starship, you can't afford that time to just wait, right, once it's offloaded. So, it's going to take literally dozens of rovers like the one that you see outside to unload a single Starship. And so we think that there's a case to be made for a large logistics delivery platform. And so from that point of view, a lunar rail makes a lot of sense, but only once you've reached a certain critical growth phase in the lunar economy. Again, bringing that theme back to the different ages of the economy that you're about to hear about. So on the far right, you can see how this scales. Lower cost per kilogram, per kilometer, as we lay more and more track and as there's more and more demand. So we'll talk a little bit about the temporal separation of this economy in the next talk. Redwire designed an orbital constellation to deliver multiple RF services to users on the surface. What I want to highlight with Redwire is the importance of commercial analysis. Not all good tech makes sense from a commercial point of view. So Redwire came in with the proposition that a phased array for radar and space-based solar power generation made a lot of sense. We certainly agreed and said, let's look at it. But when we investigated it further with a commercial lens, it turns out that the amount of power being received by the end user, when you compare that to the massive aperture that it takes in space to deliver that power, the dollars per unit kilowatt were just insanely large. We didn't think anybody would pay that. So Redwire pivoted, a great example of a company saying, all right, we did the analysis, it didn't play out, and they moved on to combining synthetic aperture radar and moving target indication services with the same combined aperture. Sierra Space is our other ISRU company. Their carbothermal reduction design integrates a fuel cell. So this creates a night survivable plant. Money never sleeps, right? I've said this over and over again to the teams, and I'll say it here. We do not have a commercial lunar economy if we can only operate during the lunar day. We need to do more than survive the night. We need to manufacture and produce through the night. So Sierra has been figuring this out. They've figured out how to use things like chemical conversion for recycling and for storage. And they're thinking about a design that maybe leverages the high temperatures of ISRU to create some form of useful electricity. And finally, Starship from SpaceX is not just a human landing service provider. They are also a huge enabler to the lunar economy with just an unprecedented amount of mass that can be delivered in one shot. We've been pushing SpaceX to think about other uses for Starship. They came in with some innovative ideas for using. I mean, this, once it has delivered its cargo, is essentially a 50-meter tower, right? Great line of sight. You can use it as an infrastructure hub, integrate other services with it, and network these together, as you can see in this lower left picture, to, again, create these hubs that can become centers of economic activity. All right. So here we are, back at, that was a blitz through 13 companies with some pretty innovative ideas, but also, hopefully I gave you a few previews of how those link together. But even that is a preview. There's a lot more work, value chains, analysis behind all of this. You're gonna get a sampling of that in the next talk. So if you have questions, please bring them, check out the background material that's online, and let's talk about it at the breakout sessions. Okay, I'm going to end with a few topics, as Phil previewed, that I believe have some runway for additional work. These are new insights and intersections that were not immediately obvious when we started Luna 10. So think of these as just a few examples of the types of insights that we can create when we make companies work outside their individual IP silos, have them come together and figure out those inputs, outputs, and limitations. The first is this new concept of re-ISRU, or recyclable ISRU. We're used to thinking about in situ resources as things that are available on the moon from the regolith. But as the cadence of things landing on the moon start to pick up, you can imagine that there's more stuff on the moon that's man-made, especially in this current iteration we're in, where a lot of things going to the moon don't survive the night. That defunct, out-of-power lander could be a resource. It is part of the in situ environment now. So that's a lot of aerospace-grade metals. It's a lot of carbon that's not native to the lunar surface, just sitting there. So can we create a market out of that? And what we found is yes. So think robotics as a service to disassemble these man-made structures, and then a company like Lunar, for example, to do metal recycling. And from that, you create products to feed something like the lunar rail. So together, that value chain that goes through robotics as a service, into metal recycling and over to the lunar rail, that you'll hear more about value chains in just a moment. But you can imagine that this can reduce the mass that you need to bring to the surface. As you can see in this bottom left diagram, we think that there's a place kind of below the black line where as the costs to launch are high, which is what's on the x-axis, that you imagine that there is a place where metal recycling on the moon is, of course, the cheaper way to go. But as the economy starts to scale and launch starts to get cheaper and cheaper, there's a crossover point at which it's just cheaper to bring metals from the moon. So this is an important takeaway, we feel, for the economy at large. As it scales, not every service will be as profitable. Some will increase in value, and some will need to pivot. That's okay. This gives us an idea of what are the foundational services that we need to fund today, and which ones call for big investment once there's a lunar infrastructure that's already in place. Okay, next, the lunar economy is going to be diverse. All kinds of users, they're going all kinds of places. Their power needs are just as diverse. There are places where wired power makes sense. There are places like permanently shadowed craters where wired power may not make sense. So wired power will be a difficult commercial move for anything that's trying to extract resources, at least at first. For example, ISRU is going to be power limited, and so it's not going to be able to go very deep. It's going to go wide in terms of collecting regoliths. So if it's mobile, wireless power may be a better solution. I talked a little bit about satellite retirement at a cislunar hub as a new paradigm. We think this idea of contributing services to a larger whole becomes interesting. While the satellite still has some fuel, some comms capabilities, some compute that it can contribute, that then becomes a shareable resource that can go across the hub in a sort of harbor master model. And as this hub grows and more spacecraft add to it, then this becomes the home of other things in its own right, things like space domain awareness payloads, edge compute, refueling services. I think of this as sort of the Ramstein Air Base of the lunar industry. As I mentioned, I've been surprised by how fundamental robotics as a service can be. And I do think if you want to bootstrap the lunar infrastructure and not constantly be resupplying new units, the moon is a harsh mistress after all, you're going to want to design your lander or factory or item, unit, to be compatible with robotic maintenance, robotic unpacking, maybe, and we can do a lot of that with teleoperation. Now on the right, far right, is an example of how those tall networked towers of power can link an area of regard, right? You can imagine a series of these towers across an area like Shackleton, creating a power and data umbrella that benefits everyone that's working in that area. As I mentioned, such towers can provide services both at the masthead and at the base. You can see an example of some of those services, but here's one example that, as Phil mentioned, we found a little bit interesting and surprising. Under Luna 10, I think we've come to realize that this idea of thermal as a service is foundational to the lunar economy. As I mentioned, we don't have a commercial lunar economy until we can not just survive the night, but operate through the night. And so everything, every lunar user, needs both heat rejection and heat during the day and heat generation during the lunar night. And because of those massive thermal extremes and the lunar night being 14 days long, we find that a lot of units that ship to the surface end up being 40 to 50% of their mass is just the thermal system. So if you can imagine unloading that, then you either have reduced your cost to the moon by half, or you have doubled the capability that you can bring. And so think of this as an HVAC. It's exactly the way an HVAC in a skyscraper works, right? Each floor has its own individual thermal requirements, but the one HVAC system handles and centralizes it all and handles all the demands. You can also imagine that this would be the start of a lunar village, would be around these hubs. I mentioned cross-mass and logistics, so I won't touch on that too much more. All right, let me close with teaming. At the start of Luna 10, we hypothesized that because the moon is so expensive to get to, there is an advantage potentially to teaming, even with the competitor, just to get started, and then create a framework where companies can buy services and sell from each other. In the fall at LSIC, I mentioned this idea of A sells to B, B sells to C sells to everyone, D brings it home. So in the next presentation, we're going to be much more specific about who's A, B, C, and D, and what are their interfaces. So we wanted to think with Luna 10 about how we move from this era of where we are today, which is fractionation. Everyone brings everything they need to survive, and move to an era of cooperation and interconnectivity. So this is one snapshot of a team assignment that we gave to performers to explore the interconnectivity between specific services and then define how that boils up to the framework level. So what I'm going to do now is pass it over to two members of our government team, starting with Liz Hyde from the U.S. Geological Survey. And she's going to start us off by digging into the lunar framework, so the next level of the wedding cake, if you will, and talk about how these and others can evolve from where we are today to a thriving lunar economy just a few years from now. I'm going to briefly, I'm not planning to explain these, but these are white space charts that our performers developed. And you can think of these as technological white space that we're not exploring in various areas. How does a particular service scale? What is the value proposition that it brings? And what are the new areas that we can explore that are perhaps worthy of investment we're not making today? Liz, over to you.
All right, is everybody ready for the next fire hose? All right, so I'm Liz Hyde with the U.S. Geological Survey. I'm an aerospace engineer, and I'm here with Sean Britton from NASA Langley, and we are representing the Luna 10 Government Integration Team. What is the Government Integration Team? That's a great question. So we're a group of subject matter experts from various government agencies, and our role in Luna 10 is to take all the products and data from these performer teams and assist DARPA in turning them into the products that we're going to demonstrate today. So here's our wonderful team. It's been a really great, past few months. What I'll be presenting today is the frameworks, which demonstrate what the lunar economy will look like, and then Sean's going to present value change, which explains how do we get there. A couple caveats, just, these frameworks are a version of what the lunar economy looks like. We're not saying this is the lunar economy. We have made a bunch of assumptions. The error bars are pretty large, as you'll see, and there are going to be gaps. And so what we're really trying to do here, especially at LSIC with this very collaborative atmosphere, is to start the discussion and get feedback from everybody. What assumptions are wrong, what error bars can we improve on, and what things are we missing. So once again, come into the breakout sessions, throw daggers as you will. We're really excited to hear what you all have to say. Another big question is, what is the lunar economy? And everybody likes to ask, what is the gold nugget? And if you were expecting the USGS person to come here and tell you where the gold is, I'm sorry to disappoint. But what I will say is, we're going to be using this analogy a little bit, but before even gold was discovered, there was other economic drivers that built the infrastructure so that when gold was discovered, it was a lot easier for the rush to actually happen. With that in mind, we are presenting a framework built around the initial investment of oxygen and in some cases water. We're not really claiming what's going to go on beyond that, and there's going to be infrastructure around that, and any sort of market things that pop up after that will be able to use this infrastructure. We're also kind of making this claim of what a sustainable lunar economy is. It's economically positive. It converges to a state with little upmass from Earth, and it is cooperative, international, and interoperable. These are kind of high-level assumptions for these frameworks. This is from the RFP, so they're kind of listed there. We're focusing on robotics, not touching human spaceflight at all, avoiding the use of government infrastructure like DSN and the like. We're focusing on cislunar space and the lunar surface, not so much on down mass, no nuclear power, and we're not making claims of a specific spot on the moon. We're just sort of presenting options, and it's a very high level. We're not getting into the too nitty-gritty here. As kind of alluded to, what's sort of come out is we found these 4 ages of that technology has been broken into: exploration, foundational, industrial, and jet age. The dates on the chart are kind of notional, but what the real thing in here is as technology and equipment populations mature and the need for further infrastructure grows, you kind of have these kind of breakouts in technology. The analogy is kind of moving from trails to roads to rail and then to the skies. So without further ado, we're going to start with the exploration age and Lewis and Clark's Fort, which is that picture, which is where we are now. Currently have a bunch of self-sufficient kind of one-off missions, and you're using what you are bringing with you. You don't have a grid to plug into. You have a really purpose-built mission. You're not having a whole lot of interoperability. Missions are short. Maybe you're not surviving the night, or maybe only a couple of nights, and your area of operations is based off your landing craft. You don't really have a lot of sourcing from one area to the other. But this is also where we're doing a lot of exploration, exploration, trying to figure out where reserves are, trying to figure out where that economic bases will be in the future. This is also an area where tech demos kind of come about to enable the future technologies. So here's our first framework slide. As I said, this is kind of currently where we are. We have a couple landers here in the form of Blue Origin and SpaceX. And we just have this kind of really rover based around the lander organization. The red and yellow lines are showing communications lines, both local area and direct to Earth. And that's pretty much the only service outside of launch and launch support that exists at this time, and from a commercial point of view. You notice the little icon MVE. So an MVE is a minimum viable experiment. That's kind of the tech demo side of being able to test out these technologies that we're going to be using in the future. Going along this is sort of what the economy looks like at this scale. As I said, the only real things we're making money on right now is launch and communications, and it's pretty expensive. This is, communications, you can kind of see at the top there, we're on the order of tens of millions of dollars per month for a data subscription, kind of a lot. but it's kind of the only thing we have at the moment. Launch is still expensive. There's not a lot of competition. But after we blaze these trails, we can get to the foundational age. And here we have finally moved to where larger, heavier, and faster rovers are enabled by having roads to ride on. Standalone power and PNT infrastructure is starting to roll out, so we're not so dependent on our own systems, on our own hardware. We're still using tech demos, but we're starting to, especially in the ISRU side, now we have reserves. We can now actually test our methods and start to having the birth of a functional ISRU economy. Launch costs are starting to decrease, lowering the cost of the barrier to entry. Orbital comms, PNT, and traffic management systems are starting to be implemented. Here's the ground level view, and I'm trying not to repeat stuff from the previous ages, even though that laser link still exists, but we're focusing on the new stuff. Sort of at the left, you can kind of see the beginning of recycling with the idea of using old fuel tanks from landers as oxygen storage tanks, now that we're starting to produce oxygen on the moon. We still sort of have the landing sites as the nexus of activity, but now we have a road between them. So we can kind of start expanding the area of operations a little bit and expanding the interoperability between these landing sites. Looking at the lower left, we can also see the construction robots beginning to work on the lunar rail. So we kind of, this is again the tech demo side of trying to progress to the next stage of development. And in the center, you can see the Honeybee Lunar Saber, which is providing a bridge between the two landing areas in terms of infrastructure services with power, and providing a tower that can house various communications payloads. Also near the center, you have our ISRU plants with Sierra on the left and Helios on the right. They are still in their infancy. This is kind of a tech demo phase for them as well. We're only on the order of 100 kilograms of oxygen a year, which isn't enough to refuel a Starship, but it's enough to get started, and you can start having that stuff on hand to see if there is a more industrial use for that oxygen in the meantime. Lunar is also starting up their recycling plant, with being able to use regolith and whatnot to kind of start their process of reprocessing metals for the upcoming lunar rail and for just general other use. And finally, now that mining reserves have been determined in the exploration age, functional mining begins to feed the oxygen reactors. We don't really have mining rovers in our scope in terms of any of our performers, but we know that that's a technology that's there, and all of this infrastructure is going to support them. But we do have robotics as a service that is alluded to with ETI that can load and unload from the rovers to the ISRU plants. And finally, looking up into orbit, our early PNT and communications relays start to appear. We don't have full coverage yet. We may not have the most accurate measurements, but it's the first step in the process, and you're at least getting your initial users into your system that can grow over time. Oh, that's the chart I want. So compared to the exploration age, the foundational age has a lot more going on. Diverse services become available, although they are still pretty expensive, and they're still limited in scope, talking about PNT coverage, communication coverage, and the like. From the power perspective, in addition to lander-based power with the Honeybee Tower providing power, as well as hosted payloads and power beaming services, the cost of these services is high, but it is covering a more area, wider area than the previous age, and there's just another vendor out there that you can work with. In addition to solar power, the Sierra Space Reactor has a fuel cell that can provide night power, which is another bountiful asset as we try to not just survive the night, but thrive the night. And then as the ISRU plants have material available, but may not be cost comparable at this time, but we're getting there, especially as the cost to launch comes down. Robotic later, we're starting to mature with the GTI, inchworms, and rovers providing services on demand. These services are about 20K to 40K depending on, per hour, depending on what you're doing. But this is also, that's not including the communications price. And so, at this stage with communications price being so high, you're kind of limited to more simpler pre-programmed autonomous operations to keep those communications and power costs down. So while driving on roads is fun and fine and dandy, once your economy reaches to a level where you just have a lot of stuff to move around, rail starts to be a really attractive option. This need for material and its supporting infrastructure is the sign of the start of the industrial age. As with the Transcontinental Railroad of old, the Lunar Rail forms the backbone of the logistics during this new age. Large excavation class rovers are needed for both rail construction and can also be used for large-scale mining operations. The pilot plants, or the forts of old, become obsolete and they become a resource in their own right in the form of large-scale metal recycling. Orbital constellations have full coverage over the economic base area, both local and Earth. Downlink comms are robust enough that teleoperation starts to become more realistic and large-scale power generation is realized. While the jump from the exploration age and the foundational age brought in a lot of new technologies, the jump between the foundational age and the industrial age is more about scale. So there's not a whole lot of new technologies, excluding the train, but the size and scope and the economic output of all of these services is different. This is really apparent in the center with the oxygen plants. We're still not making enough to fill a starship full of LOX, but we have increased by an order of magnitude, just in this jump of time. The Lunar Sabre network has expanded to multiple sites with mesh networking between them, just expanding our potential area of operations. The orbital assets like Parsec and Redwire have grown in size to have full coverage over these areas, not just one satellite occasionally flying by. The Firefly aggregation hub has also grown and now can provide cargo and transshipment points as access to launch becomes more available. Coming back to the ground, the amount of excess hardware has grown, but so has the ability to recycle it. So we kind of have our scrapyard there in the corner. This is kind of symbolic of old obsolete technology that Cislunar can use to create new, mostly metallic hardware. And now they can have up to 500 tons a year, which is quite a bit. In order to support all these heavy loads of oxygen and metals and the like, the Lunar Railroad is realized and continues to grow. Supporting that is a cadre of rovers performing a variety of construction tasks, including excavation, assembly, and fabrication. ICON is also at work not only supporting the roads built in the previous age and supporting the rail, but also starting to make landing pads for the various landers to have, once we start getting a higher volume of launch to the surface and making that less risky and more efficient. Looking at the economy side of all this, this is where the effective scale starts to really show. You can look at the honeybee numbers, I think are interesting ones to track on these slides. And these are basically prices that are going down because launch is cheaper and they're starting to recoup their investment costs. Looking at the payloads that Honeybee's hosting, which is kind of under or to the side of the tower. From FiberTech and Crescent, their costs are also going down in response to their host providers' costs going down, as well as overall power costs going down. The robotic numbers look like they've stayed the same, but really, they're also really tied into communications costs. So again, as communications costs goes down, you can either have cheaper robotics as you were doing in the previous year, or you can spend that extra time to have more robust communications to do more complex tasks, sometimes involving teleoperation from areas outside the moon. As large rovers and rail cars begin to deliver large amounts of regolith, the oxygen production rates start to increase, and the costs begin to go down. The amount of excess material increases. Oh yeah, as we get more and more stuff on the moon, Cislunar can now produce more material. Their costs are also going down. This is just the economy of scale once again. And then in the transportation sector, not only do we have we still have our roads and our rovers, but we also have this lunar rail which at 20 kilograms per kilometer, starting to compare to terrestrial freight rail. And ICON is also now beginning to recoup their investments on the landing pads by being able to charge landing fees or takeoff fees at these landing pads. It's kind of throwing a lot at you, and now to look at the sci-fi future we all want, the jet age. This is where we finally realized translunar and back to Earth rocket transportation on a regular basis with fuel made on the moon. We have full PNT, coverage, not just limited to certain areas. And we are able to not just survive the night, but thrive the night, and just be able to work at all hours. This is just, an expanded version. The major things here are these large, robust landing pads that you see on the right with Icon and Starship over there. And then just, costs are still coming down. If you look at cost slide, but we have a large jump in oxygen production, which is going to enable all of this cross mass in the economy again. As we have more abilities to launch, cost comes down, and everything starts to be, so the economic model is starting to close, or it has already closed at this point. So if that wasn't enough of a fire hose, I'm gonna bring Sean up, and Sean is gonna tell you all the technical steps needed to make this work.
All right, good morning, everybody. Thank you for spending day 3 with us. We are glad to see so many people stay around and engage with us here on the Luna 10 study. My name is Sean Britton. I serve as the co-lead of the government integration team. We have to have a cool acronym, so we call ourselves the GIT. If you hear me say things like we and our, I'm talking about the GIT. It's not just Liz and I. We have an entire cadre. And big thanks to the cadre from our other government agencies that have been able to support us and assist us in the work that we've been able to do. And honestly, let me take this opportunity to thank Dr. Root, Dr. Nyack, the STO, SETA team, the performers, and everybody involved in this DARPA study who has helped us get to this point today where we can present this DARPA product, the framework that you are seeing and the value chains that I'm getting ready to go into a little bit of detail on. I would be remiss if I didn't say that this is a DARPA framework for a DARPA study. And so it is not inherently a directive of any of our single government agencies in terms of framework or recommendations or guidance. So with that being said, and Dr. Root, thank you for the great introduction to value chains in your remarks this morning. Let's talk a little bit more about these value chains. Liz has done an exceptional job of laying out that technical framework of what it looks like for the performers on the lunar surface and how they're going to connect and the inputs and the outputs that are associated there. But we also need to dig down deep into what are the operations that are going to be performed on the lunar surface and where they're going to be performed and when they are going to be performed. And so looking at one of the foundational tenets of the Luna 10 study is for a viable, commercial, sustainable lunar economy. We actually turn to a tool that is traditionally used in economic development, not necessarily technology development is what you think about when you think about value chains. Now, this is not the first time the value chains has been utilized in the space sector, and we recognize that, but we feel that when you couple it with everything that Orbit was able to overview for our performers in the development and the systems that they have been able to create, and Liz with the technical framework that she's been able to present, it gives us a deeper insight into where we stand from a technology development perspective, maturation of those technologies, and then maybe where we actually need to apply a little bit more focus in terms of technical gaps that need to be closed so that we can have these operations on the lunar surface. So where did the GIT start? We started by identifying 5 foundational functional areas on the lunar surface that we wanted to look at these operations. And Orbit was able to mention them real quickly: transport and logistics, power, comms, PNT, and ISRU. You don't see robotics up there, you don't see construction up there. Why? That's because we consider them cross-cutting technologies, and as Orbit was able to expand, that robots as a service is inherent to almost every single one of the value chains that we're going to talk about. So we've got our 5 functional areas. Let's go ahead and break that down into a value chain. Value chains have been around since the 80s. Michael Porter invented them back in the 80s. And the idea and the concept behind them, if you're not familiar with them, are you're going to lay out the systemic operational steps that are required to get a product or a service from inception to your customer, delivering the service, delivering the product. So we had a challenge here because we wanted to make sure that we covered those functional areas adequately, and we wanted it to serve as a foundation for any use case we could think of. We also didn't want it to be so granular that we couldn't tell what was going on. So kind of a real Goldilocks approach we had to take this with. We didn't want it too vague, we didn't want it too detailed, because we want to be able to drill down with our specific use cases on a common foundation of these enterprise value chains, which we're getting to here in just a couple of minutes. We then could create our use cases. Once we had our use cases, we could drill down into those specific use cases to look at the individual tasks that would be necessary for the accomplishment of them. And so through that, we could do a comparison for each of our use cases on the degree of complexity and the advanced degree of difficulty on those to see where we need to spend time and attention or where we already have adequate approaches to it. 5 enterprise value chains, about 19 different use cases is what we are looking at currently. And if you see something up there and you're like, why didn't they think of this? Or why didn't they mention that? Good. And I want to see you at the breakout session so that we can talk about that. Because as Liz mentioned, what we are presenting today is a framework, a construct. It is not the framework, the construct. And so we are opening this up and we want to hear from the lunar surface community on what they feel is important for us to be looking at. And you can tell from these value chains that they both look at kind of a crawl, walk, run approach to what we're going to be doing on the lunar surface. And we'll talk about that both from a spatial perspective and a temporal perspective. Spatial meaning, is it just early exploration phase and it's staying right there at the lander? Is it into the foundational phase where spatially it starts moving away from the lander but still within relative proximity? Has the foundation been built strong enough that you actually now can extend out kilometers from wherever your landing site is, and now your sustainable system has gotten larger and is expanding? Or in the jet age, do we have multiple landing sites, multiple sustainable economies that are across the lunar surface? So we'll look at these a little bit more. I want to talk just a little bit. Some of you guys have already been out looking at some of the posters that we have out there in the entrance. Thank you. That's awesome. That's exactly what we want to do. That's what we want to talk to you about at the breakout sessions. So as Dr. Root was able to show, we have an enterprise value chain. That is the same for every single one of the use cases within that functional area. That's that comparison. And then when we drill down into the individual use cases, as you can see here in kind of the middle illustration, some of them, say for a primitive path rover, what are you going to do in terms of route preparation, the way that you're going forward? What do you need? Well, you might have a robotic arm that could clear an obstacle out of the way for you, some form of a cattle catcher, using the analogy that we have of the railroad. But there's not much more there for a degree of complexity at this point in time. Going to an improved road rover, where these are large mass vehicles that are carrying cargo and actually performing the logistics services that we need for the future, multiple levels of civil engineering type activities that are needed. And it gets even more complex when we start talking about lunar rail. So that's a one-to-one comparison for each of these value chains we can do. And as Dr. Root showed, we can align the performers that are within our Luna 10 ecosystem to what they're working on now based on their system concept reviews. We can then go ahead and evaluate from what we're doing within Luna 10 if we have it appropriately addressed and identified, or if there's an additional focus that needs to be applied there. And that's where we can come to the community and start talking about what we can do in the future in terms of technology development. So I showed you the 19 use cases. This is another way to look at them that aligns with the 4 phases of the Luna 10 decade that Liz was able to present. And it shows very easily that crawl, walk, run iteration that we have set up for these use cases. Primitive path rover is where we're at right now in the exploration phase. But as the economy grows and builds, we are then going to be looking for improved road rovers. We continue as it matures into the industrial age. Lunar rail is what we're going to be looking at. And then very closely behind it, as we have multi-nodes within a capability, we're going to be looking for some forms of intra-lunar space travel. And this follows on for comms, PNT, ISRU, and power. One thing that you will note is some of the early value chains, some of the early technologies that we are talking about today will be sustainable throughout the entire sustained presence on the lunar surface, such as wired on-facility power. You're always going to need that. That's always going to happen. There are other capabilities that we will need and will be predominant now. But as technology continues to mature and develop, we see that importance fading away and being supplanted by other technologies, such as return to lander-based PNT, transitioning over to two-way ranging. So what does one of these actually look like? All right, so we've got one up here, and along the top you can actually see this is one of the enterprise value chains. Enterprise value chains breaks it up into those discretized different individual activities that are required. This use case that we're looking at is a primitive path rover, early exploration phase type of a rover. Now, just simply due to chartsmanship, we've broken this guy up into two individual slides. And it actually works out well because we have some natural functional gates. You got to do something before you're ready to move the rover, and then after you have started and you've embarked with the rover. And so it breaks down into these steps. You've got to build the rover. You then have to deliver the rover to the lunar surface. You're going to have to stage it. You're going to have to fuel it. You're going to have to prepare for your trek. Where are you going? What are you going to do? And then you're ready to embark. Now, we've talked about all these different value chains. In essence, it's actually a value net. There are cross connections between these individual value chains that we've set up. And you see that at the bottom by the hexagons. The comms and PNT are going to be important to make sure that you've been able to successfully deploy, position, and commission your vehicle. Power, charging, yeah, they go hand in hand. In addition to that, this is a technology development study that we have been doing, but there are going to be connections to the greater lunar surface community that aren't necessarily inherently technology development activities. And we indicate those at the bottom in the parallelograms. These are, if you are familiar with the enabler workshop that we had in February, these are connections that the government integration team has looked at and evaluated. These are other areas and possible infusion points for activities such as logic to get involved in the value chain construct that we've been able to set up. So you've got 7 primitive path rovers from different providers, and they all want to press the go button at exactly the same time. There probably needs to be some form of a regulatory guidance on who's going where, who's talking to who. You're not going to cross-cut in front of everybody. Again, we're talking primitive path rovers here. Once we get to improved road rovers and lunar travel, this becomes increasingly more complex, difficult, and important to have. We've aligned our partners, performers from the Luna 10 network with these individual function areas to show that diverse group and the handshaking that is going to be necessary. And we also were able to drill down into the second order analysis of the tasks or the options for each of these elements within the value chain. So you can see vehicle staging, not terribly difficult as we break it up into these granular areas. And again, you can break it up into different granular segments as you deem appropriate. Unloading and deployment, placement, and checkout. Looks a lot different for lunar rail, trying to get a train on the track and actually have it commissioned to get moving. So it shows you that degree of difficulty for that. Taking a look, once we're underway, you can identify the individual partners that we have here, and you can also identify that we have a couple of lighter blue areas within this. The lighter blue areas are not a grade on the individual performers, but when we look at the second order, there are additional activities that we've broken down in the second order that we need to dig into a little bit deeper. Example I'll give here is center of mass evaluation and placement and stowage. You have a large rover and you're actually using it for logistics services. Where are you putting stuff and how are you actually getting it on and off and making sure it's safe? Very similar to what Orbit was talking about with flight cargo and something sitting on a pallet. How do you make sure that you prioritize that? Enabler capabilities, mapping and cargo inspection. Those are going to be very important for the future of a sustainable commercial lunar economy. So that's one of our value chains. We've got time for one more, And then I invite everybody to come to the poster session where we have some posters and discuss with us a couple of the other value chains that we have represented here today. The intent is for all 19 of them to be publicly released. We're looking at how best to do that and have the continued dialogue with the lunar surface community on what we're looking at here. So one more, and this is from the industrial phase. This is ISRU, regolith-derived oxygen value chain. And what we're looking at here is not just experimental exploration phase, goes, pokes the regolith, we find out a little bit, we actually see what the composition is right there near the lander. And then in the foundational phase, we actually have some experimental plants that are going ahead and deriving oxygen from the regolith. This is full-blown industrial. We are rocking and rolling. And you see the importance of knowing where the reserves are for the elements that we need. And so there's a lot that will go in to getting this value chain to this point where you think you know where the good reserves are. You've been able to say with high confidence, we're fairly certain that this is where the reserves are, and then being able to confirm that and start your mining operation. Now we saw light blue before, you see a little bit of gray up here, and that's okay. Gray is where we don't have a performer currently in the Luna 10 construct that is explicitly looking at these areas, but we know that they are paramount to the success of the operation. And so we will continue to investigate. I almost said dig into that, which would have been a very, very bad dad pun. I'm working on my spuds game. It's not very good right now. So. Again, digging into these individual areas, you can see if we were just talking about prospecting from an exploration phase age, we would just be poking in, taking a look with the mass spec, and we would be done with this. When we're talking about the industrial level, you can see that sample return to Earth is there for additional analysis. This is what our GIT members from the ISRU team working with the performers took a look at and said would be appropriate. And so the government integration team, we're all happy to talk about these different functional areas during the breakout session and talk more about anything. Did you see something that was missing here? Are there other considerations that we didn't think of? Is the operational order out of order? Are there other connections that we haven't thought about? If you've got to catch your plane or got to get out of here, by the swag table, we have these feedback cards. And you can fill these out. We're going to take all of this feedback back and continue working on what the future looks like. As Dr. Root said, we are one day closer. Thank you all.
All right, we have 16 minutes and 20 questions. And these are great questions. I appreciate that you asking them, posing them all on the upvotes. So I'm going to talk briefly, concisely, and look for further engagements thereafter. We won't address all, and I've aggregated some on my name card here to try to service as many of your curiosities as possible. There's a question that's just posed. It's a great question. I'm going to start with that one, although it's not the most, it hasn't been there as long. Luna 10 appears to focus on technology vision. What efforts have been made to include governance, oversight, or geopolitical considerations into this analysis? A great deal. You're aware, there's a White House cislunar lunar strategy. Before any of you saw any of this, we worked extensively with NASA, with OSTP, with the National Space Council, National Security Council, with State Department to say, is there a place within this strategy where DARPA can assist? It was our first hypothesis, and we were able to find a way where we could assist, collaborate, and provide value with clear guidance to the question of in what ways would we be counterproductive. And so we are trying to provide value in a way that is strictly in line with the White House strategy and provide value that goes to why is DARPA doing this? Goes to the biggest question many of you asked about anchor tenants. Like, who's paying for this? If you have an electrical grid, but no one's using electricity, you don't have much of an economy. So why is DARPA doing this? stated differently, why is DARPA spending its resources on this? My answer to the question of why not more anchor tenants, DARPA has a lot of money. We don't have any extra money. So this was a study rather modest. We could have included many, many others. We wanted to stay focused. And so in the many proposals we had, there were potential anchor tenants that said, I'd like to be involved to see how an infrastructure could value me. The challenge was in our n-squared graph, it's not quite n-squared if you have anchor tenants who are just end users. And so we prioritized those that could work together and create a network of infrastructure. Any inputs there?
I think, thank you, Phil. This slide that Liz previewed, I think, is the more direct answer to the question, which is who's paying for everything? There's something at the center that is being serviced. Today, our best hypothesis is that that is ISRU, that is mining, that is oxygen and water. That need not always be the case. And there was this analogy that Liz made about Sutter's Mill, which is, the gold rush is what we all know and remember. But really before that, there was foundational infrastructure that was laid down by the fur trading industry. So I would say that today, oxygen and water are as good a reason as any. Perhaps that's our fur trading industry. One of the shale hypotheses was this idea of widespread orbital prospecting, which is that today we know what's on the surface. We don't know what's in the subsurface. We have models. We have theories, and we have a couple of point measurements from the Apollo era. There's a lot more information that's going to be unlocked over the next 15 years or so as we get commercial satellites, low-flying, multiple landings in different parts of the moon, different geological terrains that are being explored. There might be a future gold nugget. By that point, if we don't have the trappings of an economy, we're already too late, right? That's when the exploration age then starts. We want to live in the foundational age today, and that's why we're making these moves today.
And I would love to live in a world where the anchor tenants were universities and science exploration. If such a large set of anchor tenants existed, we could foster much broader science exploration because we lower the threshold for any payload and platform to launch because we could provide all the services that Orbit and team outlined. There's several questions about the diversity of Lunar 10 performers, Luna 10 performers. As I said, we had limited resources for this study. If you have questions as to how we made our ultimate decision, that was a government decision. You can look at the solicitation as to what criteria we used if you have any questions. All right, international input. Great series of questions. In fact, I love the way one of these was asked, how are we going to ensure we don't invent a different plug, quote unquote? And that is through logic. So I'd like to turn to Orbit to explain the connections between Luna 10, that was modest, and logic, which is much, much larger, up to how many performers?
We're at 800 participants plus. So yeah, thank you. So Luna 10, yes, technology, 7 months, short, scoped, intended to answer some very broad questions and put some specificity to it. Logic, longer, 5 years, international. I will mention that we do have an international performer on Luna 10 as well, so that was open to everybody. But logic is really the place where over the next 4 years, we're about 6 months into it, and we have at least 5 years scoped out, that we imagine people coming to the table to talk specifically about commercial interfaces. Logic has the exact same 6 focus areas as Luna 10. So power, mining and ISRU, construction and robotics, transportation and logistics, comms P&T, and market analysis. Those are the 6 areas of logic. We've launched the first 2, which is power and comms P&T. A lot of work has gone into that. ISRU is coming right after to address that anchor tenancy. The goal is for this to be community-driven, right? In fact, as DARPA, we would like to step away from that organization as soon as it has some impetus. And there's some history there for DARPA starting an organization for standards and then stepping back from it. So the first thing we have to do is to define an infrastructure, how they fit together, and identify gaps. In a lot of places, we have standards that exist today, some formal, some informal. Let's adopt those. Let's figure out where we need to change something that exists terrestrially and adapt. And finally, only as a last resort, create new standards. And I don't mean DARPA creating, I mean us posing a question that's informed by Luna 10 and having the logic participants, as you mentioned, over 800, give us what they think the best answer is. What works for you?
Related question, and this one's trending, if you can trend on Slido. What's next for Luna 10? Nothing. It's a study 7 months long, we're done. So what is DARPA's interest in lunar tech development beyond Luna 10? Now that's a good question. And we tipped our hand in the RFI that said, here are our hypotheses. We'd love to hear what else. And I'll tell you, because I'm a public servant, I'll share because you're the constituents. We are now at a phase of looking at what is the return on investment. Very, very pleased with the Luna 10 analysis that outlines what could we do to bring about a thriving lunar economy by 2035 and why we think that is desirable for the nation. We are now looking at what is the return on investment, what is the size of an investment, and how large is that return, both in dollars and in terms of national priorities. If we're going to go do a thing, you want us to assess whether this is a high ROI, return on investment, because it's not just one next step, it's actually a series. And so we're in conjunction with our NASA teammates looking at, does the next step make sense, and what series of next steps? So more to follow. The glimmer in my eye is I hope we get to make an announcement at a forum like this, and I hope that you're proud of whatever follows. Relatedly, though, the Luna 10 study, of which we're very proud, is coming to an end, and we will release the full data set.
Yeah, so absolutely. We just gave you a preview to start some discussion. We don't even expect that the discussion in the breakout sessions today will cover everything because, you know, okay, I showed you $20,000 per hour for robotics as a service. How'd you get that number? So there's a lot of analysis that's gone behind it. The performers have given us that work. We are compiling it into a book that will be a product of the Luna 10 study. I'm going to take just one quick minute and talk briefly about a book that I found foundational as I was researching this program and coming to Phil and talking about what we thought could be useful. And this is a book by Mendel et al. It's called Lunar Bases of the 21st Century. It was written right after the Apollo program. And it's a series of papers that, honestly, reading it made me a little bit sad because they were clearly so convinced that before the year 2000, we were going to have several lunar bases. Well, it's the year 2000 plus, and we're not there yet. But it was a great snapshot of the science at the time, which had just been established by Apollo, the technology of the time, which was not the advanced technology we have today, and where they saw that going in a framework. And that really was, I think, foundational to this, the way that we have stitched together this problem. So our goal for Luna 10 is to create the exact same thing as a snapshot in time as of 2024. What did we explore? What are the ages? What's all the technical analysis that has gone behind it? We're, you know, kind of tongue-in-cheek calling it the field guide to the lunar economy. But really, it's just a snapshot in time, and it's going to capture what we think should come next. So that will be a series of technical papers that go into how all of this was derived, a series of enabler presentations. So those are, for those of you that were at that workshop, these are external perspectives that are still imperative to the lunar economy. That's space law, space insurance, things like that. And then finally, the sort of I'll call it illuminated thoughts of noted space leaders in the field to give some context to it all.
We are moving into some specific technical questions, which are much more fun to answer, but they're more long-winded, and so we'll see how many we can get to. A question, you mentioned biomanufacturing early in the presentation. How does this fit into Luna 10? As I said, this study is coming to an end, but the Shale RFI made clear we think it has some future, and I like the way that Liz outlined it. It could be that biomanufacturing, we hypothesize that it could be an anchor tenant of the future, potentially in, say, the industrial age, once there's a scale of infrastructure that allows for additional high-risk ventures like value derived from biomanufacturing. I'm going to skip then to some tech questions for the remainder of the Git associated with reliability analysis. How was reliability analysis factored into your analysis?
I like how it just
Rock,
keeps
paper, scissors.
dominoing down. Anybody got it? Yeah, reliability is a huge concern. Taking a look, it's a very, very hazardous area to be performing any form of an operation, be it mechanical or electrical. Looking at it from a mechanical perspective, dust permeation, dust intrusion is going to be massive and is going to wreak havoc on essentially anything that you're bringing to the lunar surface. And so that is an area where, as you saw in Liz's framework, we had started to say that about 5 years lifetime, you're going to start to have your minimum viable products begin to fail and begin to that need for recycling ISRU as they come to closure. Mean time to run or anything like that, we have not dug into yet, but in the individual performance system concept reviews that they have developed in conjunction with the Luna 10 effort, they do start to take a look at what they think are going to be their critical points of failure, what are those components of their system that are going to require the most maintenance. Again, this is an all robotic, autonomous type of economy that we've been looking at, and so what do you do if you have a part that fails? What type of redundancy do you have there?
And I would say it's not just redundancy, but it's also once you're past the experimental part of your experiment, how do you, knowing your limitations, for instance, batteries, are your batteries only going to last 2 years, but the rest of your system lasts 10 years? Do you make that a replaceable part, knowing what robotics you have on station that you can do that with? So there's been a lot of exploration of what those interfaces are, and I think that also gets back into the standards pack of being able to create products that are, recyclable, yes, but also field replaceable, in situ with robotics.
So dominating it the reverse way, I would say the concise answer to that is robotics as a service for maintainability is the thing that we have dug into the most.
And I'll have an even more brief answer, ask them. The next is a glimmer in your eye, which was, I'm going to refactor the question, should we be thinking about salvage and repurpose first in the design of spacecraft and landing materials such that it could be maximally reused upon successful landing?
Yes.
Yeah.
I think we absolutely should. I think we are just starting to crack open the can on this idea of recyclable ISRU. It's not something that I've seen a lot of in the literature. There's absolutely more that we can do to flesh out how that happens, to include salvage.
And very much in line with what Liz outlined, exploration and foundation modes would really leverage. In fact, the early explorers, there was very few exquisite tools. Everything was more like a Leatherman, did multiple things. That mindset going into landers is something I think you would support, yeah?
Oh, yeah.
Last tech question, power sources other than solar?
Yes, we have absolutely looked at, so we've looked at, the only thing we took off the table, and this is simply because NASA has a line of investment looking into it, is surface fission power. We looked at every other mode of power generation, transmission, and storage. A big part of our first hypothesis, which was thermal heat rejection and generation as a service, really trips into this idea of, especially at the equator, if you're trying to offload all of that thermal system mass, well, that's great for the user. But if you just centralize it into a hub, isn't it all a same net zero? Haven't I spent the same amount of dollars to bring it to the lunar surface? So heat storage and power storage, so conversion, right? Utilizing things like waste heat to create power, being efficient with power storage are all things that we have looked at, and we're happy to share more detail in the future.
Yeah, I think it's important that any element of energy should be capitalized on when it's on the lunar surface. And from the Luna 10 ecosystem, we wanted to hear, what are your demands? What are your power needs? Don't just assume that something's going to be readily available. Let us know what you need so then we can see. And if that is a technical gap that needs to be closed, then we can implement on that.
Let me give just one brief specific example. In the Sierra Space Design, where they're raising the temperature of their reactor to 1400 C, that is a lot of waste heat that needs to be offloaded very quickly, or perhaps they can use some of that high Q heat to turn into useful electricity and then dump the rest. So that's one good example of what you just said.
Right. Appreciate your audience, appreciate your questions. There are questions we did not get to answer. They last-minute questions.
Oh, could I just add one?
Please.
There was one that was talking about virtual versus in-person attendance for this forum. Certainly important. I just wanted to stress that for the online attendees that the breakout session is organized into 2 groups. Please keep your questions coming through Slido. We will be able to answer those in the latter part of the breakout. So just the first part of the breakout, the first session, is in person at the posters. That's more for just free-flowing discussion with the performers. We are then going to come together in another discussion, and we'd be happy to. That will be available to online attendees. Please join us and add more questions.
All right, one day closer. Many thanks.
Don't leave, don't leave, don't leave. I know we're late. Yeah, give them around though. So I do want to take 1 second though, for those that were here yesterday or those that weren't. I just want to say we talked about how this community has truly contributed to making things happen. And I just want to say how incredibly impressive it is that DARPA announced Luna 10 at the fall meeting just mere months ago. And that all of this work and coordination and collaboration has happened since, and here we are again talking about it. These communities do make a difference. With that said, we focus on the technical, we focus on what we're doing as a team and as a group, but what is also important is the leaders and the workforce development that is happening, and the chance to work together. So I want to take a moment to recognize that as well, and something we don't do very often, recognize an individual, Dr. Orbit Nyack. I don't know if everybody knows, but he did receive, it was just announced on April 15th, tax day, as a matter of fact, the 2023 AAS Award winner for industrial leadership, and I'm going to embarrass him and read it because I used the word ideating, which I really like. Michael Nyack is recognized for exceptional leadership in ideating, creating, and executing the Department of Defense's first dedicated lunar research program focused on technical paths to a thriving lunar economy by 2035. So congratulations. So everybody give him a handshake or a hug when you see him. And then I also wanted to thank DARPA for coming up with this SHALE acronym, because my Southern accent is not obvious because everybody says SHALE. Like you sounded very Southern when you talked about it, Phil. All right, everybody have fun at the breakouts.
Hey guys, we're gonna push everything back 10 minutes, okay? So take a 10-minute break. I will announce outside, everything's pushed 10 minutes.
it.